The goal for today's investigation is for you to be able to write equations in the form of y equals kx to represent a proportional relationship. And I'm not really sure why mathematicians have chosen k as the variable to represent this constant of proportionality, but we're going to use this equation a bunch. We're going to use it throughout the rest of this unit and into our next module on linear relationships, which is a special kind of a proportional relationship. But essentially what our goal is for you to be able to figure out what is this k, this constant of proportionality, and then use that to write your equation so that once you know this this value here for your constant of proportionality, you can use it to solve all kinds of things. So we'll start by looking at this problem here, where we've got a plane that's flying at a constant speed. So that's an important, I might underline that, constant speed. From Denver to Chicago. I don't care about that. I'm going to cross you out. What I do care about is this constant speed. And it takes the plane 1.5 hours to fly 915 miles. And so it wants me to complete this table. So if I think about my speed over here where it says miles per hour, well, I have here 915 miles in 1.5 hours. So I need to know how much it goes in 1 mile. And so maybe a way I could look at that would be 915 divided by 1.5. That would allow me to think about my unit rate, which is per 1 hour. And so I'm actually going to get 610 miles per 1 hour. And so since it is a constant speed, well, I know that it's always going to go at 610 miles per hour. And that's a useful thing that without doing a ton of math, I have now filled out, nope, that's miles per hour, there we go. Some important information on this table. So I just figured out this constant speed, and what that actually is my constant of proportionality. So remember, that's the thing I'm going to multiply by every time. And so if I look in here, well, I know that if my speed is 610 miles per 1 hour, well, in 1 hour, it's going to go 610 miles. There's a couple ways I could approach this next line down here. If I'm completing this table, well, one way is I can simply think, okay, well, what's 2 times 610? Or I can add 610 to this one. But either way I want to think about it, now I can use that constant of proportionality, think, okay, 610 times 2, that's going to get me 1220. I can do that same strategy for this one, which is a little bit harder for my brain to think about. So I'm going to multiply 610 times 2.5. I don't know what that is off the top of my head, but one way I could think about it is I need to add in another half as much, right, this 0.5, and so I could add in positive 305. And so if I, again, thinking about 610 times 2.5, that's going to get me up to 1,525. And so if I look carefully at this table, I notice that every time as I come down, I'm increasing by 305 miles, and I'm increasing in, what is that, 30 minutes, so half an hour. I'll just write 0.5 hours. And again, if I look even further, if I look from here down to here, well, I notice I've gone up in 1 hour, and from here to here, well, the difference between 610 and 1220 is 610. And I could see the same thing down here, like this distance right there is 1 hour. And if I find the difference between 9:15 and 15:25, it's going to be 610. And so there's two ways I can find that constant proportionality, is to sort of think about the rate of change as I move down in units in my table. And if I can come down one full unit, that helps me think about, okay, per 1 hour, right? That word per helps me think of a division problem. So thinking about the ultimate equation down here, this is just saying, okay, for any given amount of time, t hours, I can take whatever my unit rate is, my constant of proportionality, and I can multiply it times t, and that would give me that distance, right? And so when we think about how far is a plane flying out 1 hour, oh great, I already answered that up here. How far does a plane fly in t hours at this speed? Well, it's going to be whatever the time is, t times 610. And so when I go back to now this one, again, my goal was to write an equation in this form of y equals kx. So y equals kx is my formula I'm trying to plug things into. Now I'm just trying to connect it to distance and time. And so if d represents the distance and the plane flies at the speed for t hours, writing an equation, I need to figure out, well, what am I plugging in for x and y and k? Remember, k is going to be my constant of proportionality, which we identified up here is 610. And then now I think about, what did I do mathematically to figure this out? Oh, I was multiplying 610 times the time to give me my distance. And so I could write an equation that looks like d equals 610t. And so why that's a useful strategy is now I can tell you whatever your time is, I can tell you how far we're going to go. And so a good general habit I like to do when I'm faced with problems like this is start by writing down my equation. So d equals 610t, and then plugging in my number to replace each specific variable. And so since it says 3 hours at this speed, well, I'm going to see d equals 610 times 3. And if I either use a calculator or do it off on the side, I'm going to figure out that's 1,830 miles. And then I can do the same thing here for in 3.5 hours. D equals my same constant of proportionality, and I'm going to simply replace that value t with my specific value there, 3.5. And well, I know it would just add up another 305 miles, or I can multiply 610 by 3.5, and I'm going to get 2135. So writing an equation, your first steps are to identify your constant of proportionality, ideally by finding it via your unit rate or looking in the table, and then plugging it into specific places in the equation. So I'm going to work through one more example to sort of help you formalize how to write an equation. So in this example, we have a bakery using 8 tablespoons of honey for every 10 cups of flour to make bread dough. This for every is a good clue that they're thinking about. That's a proportion that they're trying to get you to think about. Hey, set up a ratio or a rate, kind of like the word per. Some days they bake bigger batches and some days they bake smaller batches. We don't really care. But they always use the same ratio. Ooh, that's important. That same ratio, they're giving me a hint. This is going to be my K, my constant of proportionality right there. So I need to start by figuring out what is my constant of proportionality. And so since they've given me this information here, that 8 tablespoons of honey for 10 cups of flour, I might start by thinking about, okay, I need to know, this is 10 cups of flour for 8 tablespoons, but I need to know my unit rate, my constant proportionality, so I needed to know it for 1. And so maybe I might start by thinking, okay, 10 divided by 8, because this is 10 cups of flour for every 8 tablespoons of honey, but I only want 1 tablespoon of honey, and so that's going to be 5/4 or 1.25. Either one would be fine. And so I know that for every 1 tablespoon of honey, I'm going to use 1.25 cups of flour. And so having this unit rate here is a really valuable place to start. So that's usually my strategy, again, is finding a place where I can figure out the unit rate or constant proportionality, because now once I know that, I can take this number here and multiply it. This one's a little bit easy for me in that I can think, well, if they're using the same ratio and they've doubled this, right, then I would simply need to double that. And that works well for an easy math in my brain, but I'm not quite sure. I'm like, well, what do I need to multiply 8 by to get to 30? It's not instantly obvious, but I can use my constant of proportionality and say, I want to take 30, and I'm going to take it times 1.25, and that's going to get me to 37.5. And so again, I just multiplied this number here by my constant of proportionality, my K value, to get me the total number. And the reason that works well is so then when I'm placed with a variable, well, I can simply write this as 1.25 times H. If I know the number of tablespoons of honey, I can multiply that times 1.25, and that'll get me my cups of flour. And so now if I'm writing an equation where I've got F is the cups of flour needed for H tablespoons of honey, writing an equation that relates F and H, again, I'm going to start by setting up this y equals kx format. This is my constant of proportionality. We found it up here, this guy here. So now I'm thinking about, okay, I knew that I multiplied 1.25. Did I multiply it by honey or flour? I was multiplying it times the honey. And so I'm going to put the H in there, and then my flour is going to go there. And so I know I can multiply 1.25 times honey, gets me my total cups of flour. And so now I can sort of plug and chug, right? I have my standard equation. Good scaffold here is to always write that equation. This is a good way that you can get partial credit. That way I can always look at your work and say, oh, did you get this wrong because you had your equation was incorrect or you did the math wrong? So I know my equation here is F times my constant of proportionality, 1.25 times H. So now I can simply plug this number in for wherever I see H, and I can plug this number in for H. And so I might write this like F equals 1.25, my constant of proportionality, times 15. And then again, I'm fine if you use a calculator for that, 18.75. I can also do it for this next one, 17 tablespoons. 1.25 times 17 is 21.25. So big takeaways from this mini lesson. 1, identify the constant of proportionality. Look for a place where you can get to a unit rate between, flour and honey or whatever it is, where you've got at least one of them has the denominator of 1 to get you your unit rate. That will get you that constant of proportionality. And then 2, plug that into your y equals kx, your constant of proportionality will go in for that k. And then relating a specific variables to your equation, thinking about what were you solving for.